Hello everyone, myself MS Bhagavadimal, Assistant Professor, AIDS Department, Subject Code CRA 332, Subject Title Drone Technologies, Unit-4, Topic Name is Drones in Inspection of Transmission Lines and Power Distribution. Drones are increasingly used for inspecting transmission lines and power distribution networks, offering utility companies a safe, efficient and cost-effective way to access infrastructure. Here are some of the primary applications and advantages of using drones for this purpose. Visual inspection. Routine inspections. Drones equipped with high-resolution cameras can quickly inspect transmission tower, pole and power lines, identifying visible damage like corrosion, crack and wear on insulators and conductors. Close range imaging. Drones can capture detailed close-up images from various angles, revealing minor defects that are often missed by traditional methods such as ground-based inspection or flyovers by helicopters. Thermal imaging for hotspot detection. Identifying overheated components. Drones equipped with infrared cameras can detect temperature anomalies on transmission lines and other components, identifying hotspots that may indicate issues like loose connections, damaged insulator, or failing transformers. Preventative maintenance. Early detection of overheating helps utility companies address potential failures before they result in power outages or costly repair. Then corona discharge detection. UV imaging. Specialized drones equipped with UV camera can detect corona discharge, an electrical discharge caused by ionization of air around high voltage conductors. Then corona can indicate insulation breakdown or contamination and can lead to power loss and damage if unaddressed. Then insulator health assessment. By identifying corona discharge, drones help assess the condition of insulators, reducing the likelihood of power distributions and improving grid reliability. Then 3D mapping and modeling. Digital twin creation. Drones can capture high resolution data to create 3D models of transmission, tower, pole and entire power grid. These digital twins help in visualizing and monitoring the infrastructure structural integrity over time. Vegetation management. With 3D mapping, drones can identify vegetation encroachment around power lines, enabling timely trimming to prevent outages or fire hazards. This is especially valuable in areas prone to wildfires, than where vegetation management is critical. Structural integrity and conductor sag analysis. Assessing tower stability. Drones can inspect the structural health of transmission towers, foundations and anchor points, which are crucial for safety and durability. Conductor sag measurement. Using sensors and GPS, drones can access the sag of conductors, which changes with the temperature, wind and load. Excessive sag can lead to safety risk and power inefficiencies. Then post-storm and emergency inspection. Rapid response. After storms, earthquake or other natural disasters, drones provide a fast way to access the extent of damage to transmission line and other infrastructure, helping crews prioritize repair and restoring power more quickly. Assessing hazard areas. In flooded, rugged or hard to reach areas, drones can conduct inspections without endangering human inspectors, providing critical information while ensuring crew safety. Then LiDAR for precision mapping. Detailed topographic mapping. Drones equipped with LiDAR sensor can create highly accurate topographic map, allowing for precise measurements of line clearance from the ground and nearby vegetation. Planning and compliance. Accurate LiDAR data helps utility companies maintain safe clearance and comply with regulatory requirements. It also assists in planning new transmission route and upgrades. Then benefits of using drones for transmission line inspection. The benefits are safety, cost effectiveness, and time efficiency. Thank you.